In example 5, we have a table that provides data on the family size and years of education for several individuals. We want to use this information to complete the following questions. First, we want to use Desmos to construct a linear model where X represents family size. So all our values for family size will go in that X1 column, and for years of education, those values will go in our Y1 column, where Y is representing the number of years of education. And then in part B, we'll calculate the correlation coefficient and then interpret this result. I've gone ahead and input this data into a table just to save ourselves the time here, but you'd want to construct that table. We can click that magnifying glass icon to get a better zoom fit for our data so we can see that pattern better. And then we can click that regression tool to add the linear regression. And we have our model, negative 1.71429x plus 22.77143. And we're also given that value for lowercase r, which in this case is negative 0.9804. That makes sense because what we're seeing in the graph is a decreasing pattern, a decreasing slope as we read that graph from left to right. So I won't rewrite our model here, we saw that in Desmos, but our correlation coefficient will be r equals negative 0.9804. Since r in this case is close to negative 1, that suggests that as family size increases, the number of years of education, blank. That's the piece that we want to fill in again. So in this case, we're talking about family size increasing. So our x variable is increasing. We know that our correlation coefficient is close to negative 1, which means these two variables change in the opposite direction. So our value for y would be decreasing. So if as family size increases, the number of years of education for an individual decreases. Because again, that correlation coefficient of negative 1 tells us we have a strong negative association. The variables move in opposite directions. Change in opposite directions, I should say. In example 6, we're given data on the number of yards rushed and touchdowns scored in a single season for 5 NFL players. We want to use this information to complete the following questions. I've gone ahead and entered this information into Desmos off screen. And when you add a new table, so the first table that we used in example 5 used the values x1 and y1. As we add new tables, it's just going to increase the index for x and y. So for this new table, these values are referred to as x2 and y2. But we set the table up exactly the same. We can still click that magnifying glass to get a better fit for our data. And if we want to avoid confusion, we can come back up and we can turn off the first graph that we created. So now we're looking at just the values for x2 and y2, which are yards rushed and touchdowns. And we can create that linear model. In this case, we get the linear model negative 0.182752x. And I actually just noticed that I have a typo in my data set here, which is why my answer isn't looking right to me. That should be a 14. So now we'll click that magnifying glass icon again. There we go. Now I'm getting the right answer. So I updated my value in my table, and now we're getting this new regression model, and we're getting a value for r of 0.0627. We can look at interpreting that value for r. We can also see how the linear model is not exactly a horizontal line, but fairly close, and that the points don't really follow a consistent pattern. So that linear model we could transcribe from Desmos. We also have a correlation coefficient, in this case of 0.0627. Then to interpret this, we could say that since our value for R is close to 0, this data suggests that as the number of yards rushed decreases, the number of touchdowns does not follow a discernible pattern. So since that value for R is close to 0, it doesn't really matter what's happening to yards rushed. There's no good relationship between that variable and touchdowns. There's no discernible pattern, not clearly increasing, not clearly decreasing.